Hey everyone, in the previous video we covered finishing up overloading the double angle brackets operators and adding, I would say, complete functionality to this class so that way it's pretty usable and that you can do various operations with this class, like setting it equal to other things, multiplying and adding it with its own data type, its own class version, and other data types itself. Here I want to create a context where we need to use object-oriented programming, or where object-oriented programming would really help what we're trying to do here. So here I have my shape2D class, and I'm actually going to create a new class that's going to be very similar to this one called rectangle. And the idea for providing this context is that we are going to see that rectangle and shape2D are very similar classes, and in the next video we're going to show how shape2D, we can make it a base class and it can do a lot of the heavy lifting in the recreation of our rectangle class. But right now we're going to create a rectangle class the hard way. So I will begin by adding a header file, and here's how I will do it. I will call this my rectangle, right? My rectangle. And this pragma once means that this header file will only be included once. If it's already been included, it's not going to try to include it again. So I'm going to make this simple include. I'm just going to include IOStream, and that will be it. So now I'm going to create the rectangle class. And when we think about a rectangle, I like to think about four things. So we'll mention that in the private data. It's going to have a length, it's going to have a width, I also think it's going to have an area, and it's also going to have a perimeter. And while this can work for shape2D, I specifically omitted it here because I'd like to show that we can have additional functionality implemented in other classes that my shape2D that's created here can act as a backbone for. With these two parameters, we know that, hey, you know what? This has some methods with area and perimeter that we could possibly use in the future, and we will. So these are the four attributes that I'm going to have for the class, and they're going to belong to the private section of it. So next comes public, and we're going to discuss the methods. So rectangle will have we will have a constructor with no parameters, and we will have a constructor with parameters. So we'll have double length and double width. Right, and here, because it's a header file, we're just going to be declaring everything. We are also going to have a copy constructor, and we need to follow the wise conventions laid out in the previous video where I talked about creating a copy constructor. So I'll have the const, and I'll have the same data type as the class, and I'm going to take a reference to something, to some name that could be a rectangle. Here I'm going for rect, but you can call it R. You can call it another name. You can complete the lowercase and have something like rectangle. That's fine too. I myself just like to use a few words enough to show what the variable is, but not give the whole thing. So these will be our constructors, and let's label that here. And because I'm using statically allocated data here, I'm not going to define a destructor for this class, and which is okay because the compiler can actually provide a destructor for us. So I'm going to leave the destructor as a job for the compiler. Next comes the getters. This is going to look quite similar to our shape2D class. We're going to have one called getLength. It's going to be constant body. When we call the function, I'm going to make that lowercase. We're also going to have to get width, but we're also going to include get area, and get perimeter. Okay, so this is new, and I do this because we have the attributes here, and I want a controlled way of accessing those attributes. Now let's get to the setters. Now I'm going to have this. These are going to be my setters. I'm going to need input for here because we need an input for setting our attribute to. Right, and I'm actually not going to get a setter for area and perimeter. Why is that? Well, because I believe that area and perimeter are both dependent on length and width. However, length and width, I would say they're independent variables. And the idea is that I want to maintain consistency and accuracy with my attribute data. Right, since area is dependent on length and width, I don't want to be able to change area without changing length and width. So because of that, I'm not going to have a setter for area. And these same principles can be applied for perimeter. So with that said, I'm actually going to work on the other methods. I'll say other methods. And it's going to be the same as the Shape2D class. I'm going to have an area that's going to have the body of calculating the area is going to be constant, just like in the previous class, and we're also going to have our perimeter. Lastly, I'm going to overload 3 operators just to keep it simple. I'm going to overload the equals operator, as well as the plus operator. Lastly, I want to overload the double angle bracket operator so that way I can print my class like I would with an integer, string, my Shape2D class, and something that feels intuitive to me. And because this is not a method, this is going to be considered an independent function, and that is because it is a friend function. This is allowing us to have permission to access the private data of the rectangle class. However, the specific implementation of overloading the double angle brackets operator, I will not be accessing the private attributes directly because I have getter functions that can do that for me. So now let's go about implementing each one of these methods as well as the constructors. Here this will be a C++ file, and I'm just going to call this rectangle.cpp. So here it's important that I include my header file, my rectangle.h, because that's where all the declarations come from. For the constructor, I need to make sure that this is part of the rectangle class. So I have the rectangle : and since this is a unparameterized constructor, I'm just going to set the values directly to 1 for width and length. And what I'm going to do is I'm going to keep in mind what I have in my header file, what I intend to create, the methods and things like that. So here what I'll do is I'll say area is going to be equal to my area method. Where's that defined? Well, it's defined right here. And I'm going to do the same thing for perimeter. And something that I'd like to keep in mind is that since these are dependent variables, these are actually quite special. And I'm going to be copying this so that way anytime that I have a circumstance where I update my length or my width, I'm going to be pasting this below it because I know that the area and perimeter must change if the length or width change. So here we go about implementing the parameterized constructor and the copy constructor. Something to notice about the implementation of my constructor is that since beforehand I know I'm going to create some setters, here I'm just going to call them. Something to notice here is that, again, the methodology that I wanted to keep going with modifying length and width is that anytime that they're changed, I want to update the area and perimeter, and this is the same. I keep this type of methodology going with the parameterized default constructor and the copy constructor. So next comes our getters. Here I make sure that all my getters are part of the rectangle class, and I'm able to do that with the rectangle : These all have const right here, so that way the body that's in between the angle brackets, the code in the body that's in between the angle brackets, is going to be constant. So that way there's no changing any of my attributes because the body of the code is considered constant. Now let's implement the setters. The set length setter is similar to the one in Shape2D, with one small difference. Since area and perimeter are now attributes and I have modified length, I am going to update what they are at the bottom after I set length, the attribute, to some value. And the same thing is happening with width. So anytime that you set length or width to a specific value, area and perimeter are going to be updated automatically, which is pretty neat. And now to implement the area method and the perimeter method. These methods should look very similar to what you have saw when we implemented the methods of the same name in Shape2D. They have a constant body, so that way whatever we used and whatever values and attributes we use don't get modified unexpectedly, and we also use the getters for an extra layer of security. Now on to implement the equals operator and the plus operator. Here we follow the same convention that we did when creating and overloading the equals and plus operator for Shape2D. Caveat is that here I have area equals area and perimeter equals perimeter. I call these methods to update the area. Something that you may have noticed is that in the plus operator you're saying, hold on, wait a minute. In temp, we have the set length and set width, but there's no call for updating the area and perimeter attributes. And I say to you that, well, they're consistently updated when we have the set length and the set width. So as soon as we call set width, and we can go up there, set width updates the area and the perimeter automatically. So that after we call the set width method, we actually don't need to update it like we do here. Now, onwards into implementing the double angle brackets operator. Here, the implementation of the double angle brackets operator is quite the same as it was done in Shape2D. And this is to highlight and to show how similar these classes are to each other. Rectangle almost feels redundant because we're using the exact same methodology and the code for this is very, very similar. Now, realizing that, in the next video what we're going to do is that we're going to start talking about object-oriented programming, mainly single inheritance. And what single inheritance is going to look like is that we're going to have our rectangle class inherit just from the MyShape2D or Shape2D class, and have Shape2D class do the heavy lifting, so that way we don't have to rewrite a lot of this code as we have done in creating the rectangle class. Feel free in this implementation to test it out and create your own main. Here is an example, and here is the updated main. One thing to note is that I included the myRectangle header file. This allows us to include the rectangle class. So here I have some tests. Here I provided two negative values to see if I can flip the signs and keep the positive values, as I did in my check for setting the attributes to a value. Here I'm putting a 0 as the second value for the default parameterized constructor to test that this is going to be set to 1. Here I create a third rectangle class where I add 1 and 2 together and test out both the plus operator and the equals operator. So why don't we see the result? So here this comes from my second shape, but now let's take a look at the second line. 8 and 5, they are no longer negative. So this means that when we call the set length and set width methods, that they're able to flip the sign successfully. We're able to have the correct calculation for the area and the perimeter. Now let's check for rectangle 2. We have 9 and 1. This is good because this caught that the second attribute was going to be set to 0, so set width set it equal to 1. And here we see that the area and perimeter are correct. So lastly, we test our third class with being equal to the sum of two other classes of the same type. So we add 8 and 9, which is 17. That's correct. We add 5 and 1, which is 6. If we multiply this together, and check that the sum of these two times 2 is equal to the perimeter, we know that this is correct. So now that we set up a context for why we need to use object-oriented programming, in the next video we're going to talk about how we can make Shape2D something called a base class, meaning that other classes can inherit from this base class. Thank you.